Hello, I'm Channa Bankapur. I'm going to discuss my solution to the LeetCode problem partition equals subset sum. It's today's daily challenge in LeetCode. The problem definition is we have an array of positive integers and we need to find if the array can be partitioned into two subsets such that the sum of elements in both subsets is equal, right? This problem can be reduced to the knapsack problem. Knapsack problem is a popular problem in computer science. Uh, Knapsack problem is an optimization problem, but the current problem, partition problem, is a decision problem. Let's see how we can actually use knapsack problem to solve this problem. In the knapsack problem also we have like n items, but each item has two different things. One is value and then the weight, right? So there are two things for every item. And there is something called capacity or target of the knapsack. That means the knapsack cannot hold more weight than this target weight, and we need to find the most valuable, subset. So, valuable in terms of the sum of the values of the subset we choose, which fits into the knapsack. So, fitting is obviously and with respect to the weight, right? Um, so how do we solve this problem? In this partition problem, we can there are only one there is only one value for each item. So both value and weight can be treated as the same thing, right? So both that value, whatever the value we have, acts as both value and weight of the item, and the target would be sum of all the items, which is sum of all of them divided by 2. So this is going to be the target. Why by 2? Because if I find a subset which is equal to this target, then the answer is yes to this problem, right? Otherwise, no. So we can solve this knapsack problem with this as the target, right? Which is sum of all the elements divided by 2. And if the most valuable subset is equal to that target, then the answer is yes, otherwise no, right? So that's how we can solve. And we know this knapsack problem can be solved with big O of n into t being the target value, right? So because these are integer values, it can be done. If you look at the constraints of the problem, n can be as much as 200 and t can be as much as 10 power 4, right? So it's about 10 power 6. So this should be we should be able to work, right? So we can solve using the same method. Let me show you again from state space tree method how this can be solved. We have n items to solve for, and then we have a target of t, right? And so each time whether the item can be chosen or not chosen, if the item is not chosen, we're going to solve for n minus 1 comma t. If item is chosen, we're going to solve for n minus 1 um, t minus the value of this item, which is nums of the last item, right? Maybe I'm going to call it as n minus 1. If n items are there, n minus 1 is the index of that. All right, but this is only if the target is greater than or equal to nums of n minus 1. Otherwise, we cannot choose this, just like in knapsack problem. So if any one of them says yes, the answer is yes. So I'm going to OR both of these results, right? So that's why f of n comma t is going to be either f of n minus 1 comma t or f of n minus 1 comma t minus nums of n minus 1. N indicates the number of elements. And the base cases are if the target becomes 0, it doesn't matter how many elements are there, the answer is true, right? Because we got the exact, the subset equal to the target, right? Target reduced to 0. If target is not 0, but n is 0, right? Target is something like greater than 0. In that case, it is false. The reason is we don't have any more elements to consider, but the target is not at 0, right? And there are other cases with this if condition, they're going to prune the branches, right? So this is the whole recurrence. If you implement, you're going to get it. And if you see here, if I naively implement, the time complexity is going to become 2 power n because every time you're taking two choices. But average case is better, but still exponential. But if you see, there are overlapping subproblems already. And if you look at the function also, there are only two parameters. And the dimensions of both of them is the first one is n and second one is t. So it works in big of n into t, right? So t being a discrete value here, this is simple and it's not too huge. So this is better than 2 power n. N being about 200, 2 power 200 is too huge, but 200 into 10 power 4 is manageable, right? So it's a quadratic type picking algorithm in a way, all right? So obviously the idea is what's called dynamic programming, and you can either use memoization to solve it, which is going to be top-down way, but if you can directly make it bottom up using a table of DP table, you can use it of the size of n into t, actually n plus 1 into t plus 1, and you can initialize these base cases. So these are true values where for every row in the first column or zeroth column, it's going to be true, and first row on the other end is going to be false, except for the first value, right? And then you can solve for the value of n comma t. All right. So this is I already implemented the bottom up way of doing it. Let me show you that. Um, so look at this. I first find the sum of all the elements here, which is going to be sum in this array. And so one special case is if sum is odd, obviously we cannot split into two subsets, right? Because all of them are integer values. So I can right away say false, right? It's a necessary condition that has to pass. Sum needs to be even. And then the target is going to be sum divided by 2, and n is this number of elements, and so I'm solving the knapsack problem, right? I called it knapsack problem for the similarity here, but otherwise it's already modified accordingly, right? So the bool table is, or sorry, the dp table is going to be of boolean value, because all we need to know is whether it is possible for that for the number of elements and the target, right? So, and as we have already discussed, these are the base cases. I'm setting the base case of, the first column as true because the target reduces to 0 and we have a solution there. That means we have a subset. Otherwise, the first row except for the first column is false because there are no items to choose from. The target is not at 0, right? And in this case, I'm running from I equal to 1 to n and then j equal to 1 to target. So every time I find, these are the two cases we consider. First, I just initialize with the without case. Without case is in the previous row, the same column, because one item is ignored here. Ith item is not considered. Otherwise, I'm going to consider the with case, but for the with case, there is a condition also. The condition is so in this case, yeah, so first of all, j should be greater than or equal to nums of I minus 1. That means the current weight or value should be greater than or equal to whatever nums of I is, right? The ith item, right? Ith item is in I minus 1 position, right? If that is true, and also the previous problem is also true, then I'm going to set dp of I comma j as true, right? So one of these two has to be true, right? With and without case. And then when I solve, finally the answer is dp of n on target, right? So let me show you that we already discussed time complexity. So it is accepting, and also the space complexity also is same here, n into t. But yeah, space can be reduced because it's a decision problem. I don't have to construct a solution. We can actually reduce this into a lesser space, but the space can be reduced to only two rows. So we can reduce it to, instead of big of n into t, it can be big of only t. There is a simple trick to do that. Let me show you that. Instead of having n plus 1 rows, I can have just two rows here, right? So those two rows, I keep using it. So in this case, I don't need to run for all the n plus 1 rows. I just have to run for twice. So it's going to be either min of 1 comma n, right? So until either I is 1, or if n is even 0, so we can stop there, right? So in this case, I need to always take the mod value of this. So I always bitwise AND with 1. So that way I get 0 or 1 depending on whether it's even or odd. So this is not going to change. And wherever I'm accessing the DB table, the row index, I'm going to make it as 0 or 1 depending on whether it is even or odd, right? So it's I minus 1 mod 2. Mod 2 and or this bitwise AND with 1 are essentially same. So this is little more elegant to see, as in it uses bitwise operations and it's kind of faster, right? So there are two more places to do that, and finally even the answer. So even though conceptually we look at it as like n plus 1 rows, but in reality we have only 2 rows. We are using these mod values, right? So this should also work. It's accepting here. Let me submit and it accepts, right? So the space complexity is reduced to big O of t. All right. If you see that there are not so many values, if t is much larger than n, maybe you want to use memoization. That's an idea you want to explore, right? For this problem, um, because see the overall target value, it says it's 100 for one item, but there are 200 items, right? And if I look at the half of that, it's going to be 100 into 100, which is 10 power 4, right? So 10 power 4 is not too huge, but it is much greater than n. All right, so let me know if you have solved using any other methods, or maybe this is the most popular way to solve it. But yeah, if you want to share your method, please share. Otherwise, please like the video and subscribe to the channel. By the way, today I crossed 1000 subscribers. Thank you. And so keep watching for the videos. So I'm gonna post at least one video every day. Thanks for watching.